This video shows the assembly process for my 3D printed Retrograde clock. Based on an original design by Dan from Mechanistic, this version has been re-engineered into a motor-driven clock capable of accurate timekeeping. Before getting started, you'll need to gather some tools and perform some prep work. On the screen are some of the tools you'll need. You'll need a 1.5mm hex wrench for M2 screws, a 2.5mm hex wrench for M3 screws, a 1.5mm drill bit, a 1.6mm drill bit, something to drill with, such as a mini drill, a mini hand drill, pliers can work as well, a small hammer or a big hex wrench to tap things, an M4 socket for tightening nuts, and a tweezer. You're also going to need a rotary tool to make pins. This is a stainless steel rod, 1.5mm in diameter. To help cut this, you'll need some diamond cutting discs. The length and quantities of pins are shown on the screen. For the base, you'll need to do some prep work. Use a 1.5mm drill bit to drill out the holes at the following locations. There's 14 of them. For the frames, use a 1.5mm drill bit to drill out the holes at these locations. There's a total of 7 for this set of frames, and another 7 for the other set of frames. For all of these gears, drill out the center holes using a 1.6mm drill bit. Okay, let's start with the arch pillar assembly. In front of me, I have the arch pillar, marker rear, marker, and marker front. These components are for the right side. Take the marker and tap it onto the marker rear. Then, take the marker front and tap it onto the marker. Next, put an M2x6 screw through the front and secure it with a nut in the back. You can do this with your fingers, pliers, or an M4 socket. Repeat for the left side. Choose from 3 display options when assembling your pillars. The retrograde assembly is complicated, so I'll demo both sides. First, the right side. Here are the components you will need. Pause the video to gather these items. Take a 14mm pin and insert it into the frame front. On this shaft, insert a washer. Followed by the swing gear. Then spring. Secure the spring with the M2x10 screw. Moving up the frame, insert a 25mm pin with a washer. Followed by the snail cam gear and 5.8mm spacer. Go back down the frame to insert a 25mm pin with a 5.8mm spacer. The T3 gear goes next with a washer behind it. At the top of the frame, insert a 25mm pin with a washer. Setting the frame aside, assemble the pointer and pointer gear together. Then insert into the shaft, followed by a 5.8mm spacer. Lastly, take the frame rear and align it with the three shafts and join together. Try running the assembly manually. If the pointer doesn't reset smoothly, gently wiggle the frames out to slightly reduce friction. Let's repeat for the left side. For convenience, I mirrored the last assembly. Here are the components you will need. Pause the video to gather these items. Insert a 14mm pin with a washer. Follow up with the swing gear, then spring. Secure the spring with the M2x10 screw. Moving up the frame, insert a 25mm pin with a washer. Followed by the snail cam gear and a 5.8mm spacer. Go back down the frame, insert a 25mm pin with a 5.8mm spacer. The T3 gear goes next with a washer behind it. At the top of the frame, insert a 25mm pin with a washer. Gently assemble the pointer and pointer gear together. Then insert into the shaft followed by a 5.8 millimeter spacer. Lastly, take the frame rear and align it with the three shafts and join together. Try running the assembly manually. Again, if the pointer doesn't reset smoothly, gently wiggle the frames out to slightly reduce friction. Motor assembly is quick and easy. You'll need the following items: a cord with an inline on-off switch, a quick wire connector that is 2 in, 2 out, a motor that is 1 RPM and rotates clockwise when looking at the shaft, 2 pieces of 16mm standoffs, and 2 pieces of M3 by 22 screws. Just a disclaimer, I am using a 120 volt AC synchronous motor. All mains wiring should be handled with appropriate caution and by a qualified individual. Start the assembly by unlatching the quick wire connector. Then, with the cord disconnected from power, insert the 2 wires into one side of the connector. Ensure that the wires are fully seated and no bare conductor is exposed. Then close the lever to secure them. Next, insert the motor wires into the opposite side of the connector. Again, ensure the wires are fully seated with no exposed conductor. Then close the lever to lock them in place. On the motor itself, assemble the M3 screws along with the standoffs. Moving on to the base. Pause the video to gather these items. There are a couple of different display modes. Option 1 is regular clock mode with hour and minutes display. Follow along as I insert the pins with washers. Use a small hammer if needed. First, insert a short pin at the front followed by a long pin. Next, insert a long pin followed by another long pin. Pay attention to where I'm inserting them. Then, go to the right and insert a short pin followed by a long pin. Move to the back and insert a short pin followed by a long pin to the left. Continuing on the left half of the base, insert a long pin followed by a short pin and ending with a long pin. Now for the gears. After installing, spin them gently to verify smoothness. Start at the front with C2, followed by C3. Then install T1, followed by T2 on the right half of the base. At the back, place C5, followed by C6. Then install T1, followed by T2 on the left half of the base. Go back to the front and place C1. Next, install C4 on the empty pin on the right. Lastly, install C7 on the empty pin on the left. Give the assembly a final spin to ensure smooth operation. Option 2 display mode is minutes and seconds display. Take out the first 4 gears. Then gather the following items. Reposition 2 pins as shown. Install S4 followed by S2. Then install S3 followed by S1. Give the assembly a final spin to ensure smooth operation. Option 3 takes it a step further by displaying seconds on both sides. It's designed as a kinetic art piece for enjoying the mechanical motion. Go ahead and remove C7. Then gather the following items. Remove the long pin from the base. Insert a short pin at the location shown. Place S5 at the new pin. Give the assembly a final spin to ensure smooth operation. For final assembly, install the motors, frames, and pillars using M2 and M3 screws. Once it's assembled, give it a test run to see if everything runs smoothly. It looks like things are running smoothly, but if it didn't, it may be that the retrograde frames are on too tight. Try loosening the screws. Then let it continue to run. Stop the motor once the right side resets. There's two things to troubleshoot here. One, the left side reset may be out of sync. If so, remove the C5 gear in the back. Manually wind C6 gear until the left side resets. Place the C5 gear back on the pin. Two, the pointers may not be pointing at 0 after reset. Try adjusting the pointers as shown. If the pointers continue to misalign, then that means there isn't enough friction between the pointer gear and pointer. Using another pin, remove the top pin, remove the pointer gear and pointer, reprint them with tighter settings, and reassemble. And that's it. Hopefully you have a fully running clock or kinetic art piece. If you have any questions or comments, please leave them below. Otherwise, enjoy.